depending on the variability of the product, and you would do a ratio of your Cmax, geometric mean Cmax, and AUC with a 90% confidence interval. And if you look at the top profile here, this is illustrating a 90% confidence interval, and you would accept that it is bioequivalent if it's in this region of 80 to 125. Now, when we do when we use in vitro and vivo correlation based on mean data, in this case we only have a point estimate. We don't have a confidence interval, and so the way that we anchor it to the bioequivalence limits is to say, as long as that predicted point estimate is between 90 and 111, so essentially plus minus 10%, then we would expect that a confidence interval, if you were to do a bioequivalence study, would be within those limits. So that's how we anchor in a pragmatic way to the bioequivalence limits. The third point I will illustrate through a second example. So what you see here on the left-hand side is percent released in vitro versus time. And these are all in vitro, in vivo correlation study batches. So these were all studied within the same clinical study. And we have a slow, a medium, and a fast batch. And in this example, the applicant submitted a request to extend the dissolution limit. So you can see here the two pink curves with the observed data on there are the proposed new dissolution limits. And the